Hello friends, this is Jay. Today I'm going to explain the 8th experiment of Unix Lab. The 8th experiment of Unix Lab is all about process creation. Here are the set of questions you need to explain. The first question was write a C or C++ program to create the following process hierarchy and perform the following conditions. So the first process A gets the seconds as an input from the user, and process B calculates hours, minutes and seconds and prints in HH seconds format in the process ID and parent ID of each process. So the first program was hash include IO string. So we are giving an C++ program. So hash include IO string, hash include unistream using namespace std int main. So we are giving the input as seconds, int seconds, count, enter the seconds. So we need to enter the seconds that C out, enter the seconds. C out in the sense that will be printed as output, printed in the output screen, and C in the input for the seconds will be stored in seconds variable SCC in PID equal to fork. This indicates that the child process have been created if PID equal to 0. So if that is equal to 0, we are initializing hours equal to 0 and minutes equal to 0, while seconds is greater than 60 and seconds is greater than 60 and seconds is greater than 59, seconds equal to seconds minus 60, and we are incrementing the minutes. So minutes plus plus. Similarly for the minutes also, if minutes is greater than if the greater than 50, we need to decrement the minute, and so equal to minus 60, and we need to increment the hours. So this should be given in format of hours, minutes and seconds. So we are giving a cout hours, minutes and seconds. So if you see the output, enter the seconds. I am entering the seconds is 65. So we need to get as 0, 1 and 5. So the second question is write a C or C++ program to create the following process hierarchy and perform the following conditions. Process A reads the string as input character, process B reverses the string, and process C checks for the palindrome and prints the process ID and parent ID of each process. So we need to first, in process A, we need to give the input of the string, of the string as character input, and for the process B we need to reverse the same string, and process C we need to check the given string is a palindrome or not. So the second so the second one was, first we need to give the process A as input. So the process A should read the string as input. So for this we are giving as hash include string and include stdio.h, and the header files we are including over here void main. So these are given as initializers, and print. First for the, we need to give the string as input, right? So we are giving as printf, enter the string, and scanf percentages, scanf percentages ampersand str. So int l equal to string length of a string. This gives the length of a string over there, and printf string length is, so we'll get the length of the string as output, and int PID equal to 4. This indicates that the child process has been created. If PID equal to 0, so PID equal to 0, the child process is created. Now the child process is get PID. So and again the parent for this child process, if we need to get a parent ID, we will get we can get as get PPID. This indicates the parent ID of the child process. So the for the child process, we need to reverse the string, right? So for reversing the string, we'll give as for I equal to 0, I is less than 0. For I equal to 1, I is greater than or equal to 0. And for reversing, we'll give in this format str j plus plus equal to str minus minus of I. Uh, So the reversing will be done by this loop, and the next condition was to check whether this is a palindrome or not. In order to check whether palindrome in the next child, we are creating another mm, in order to check for the palindrome condition, we need to check, we need to give another child ID. For this we are creating another child ID as PID1 equal to 4. If PID1 equal to 0, this indicates that the next child process have been created. So the child process, here we are writing the palindrome condition. For I equal to 1, I is greater than 0 and I plus plus. Similarly for and str1 j plus plus equal to str minus minus of I. So here we are comparing the both the strings, that is the string which is in the correct order and the string which is in the reverse order. If that both are equal, then we are giving this as palindrome, and or else we are giving this as not a palindrome. So let us see the output. So we are giving string as JAYA. So after giving JAYA, the string length is given as 4 in this, and the child process ID is given, the parent process ID, the child process ID, and the next child process ID is also given, and the parent process ID is also given. So after reversing JAYA, we get as AYAJ, and its parent ID will be given. It will check for the palindrome or not. Now this is not a palindrome. So the third question was write a C or C++ program to create the following hierarchy and perform the following conditions. So A reads the integer as input. So we'll give A as integer input, and B will check for the factorial of that number, and C for the Armstrong number or not, and D for the Fibonacci series, and E for prime number or not, F for the reverse of the number. And for process ID and parent ID has to be generated simultaneously. So this is the program. So first we need to give the integer as the input. So we are giving as void main and enter the integer. That will be printf enter the integer, that will be printed as output in the output screen. And for storing that integer value, we'll give in n ampersand n. This indicates that n have the integer value which we are giving, and if PID equal to 4, PID equal to 4, that indicates the first child process have been initiated. So if PID equal to 0, process B is created, then the parent ID will be given as get PPID, and the child ID will be simultaneously in get PID. So this is the condition for checking the factorial of a number. So in I comma f, for I equal to 1, I is less than n, I plus plus, f equal to f into I. So we are getting the factorial of a number. Again, the next condition was, next we are creating another child. So PID 1 equal to 4. Now again another child has been created, process D is created, the parent ID will be given as get PPID, and the child ID will be given in get PID. So for this Fibonacci series has to be done. Fibonacci series. So the condition for the Fibonacci series is given over here: d equal to b plus c, and b equal to c, and c equal to d, x minus minus, and printf percentage d. And again, the next child has been created here in PID2 equal to 4. This indicates that the new child has been created over here. PID2 equal to 0. The process C has been created, and this is to check whether this is an Armstrong number or not. So for checking the Armstrong number, we are giving while on. So that number which we are giving as integer, that will be stored as on equal to n. So if on is not equal to 0, when we are comparing, if not on is not equal to 0, then r equal to on percentage 10. So the remainder value will be stored in r. The resultant value equal to resultant into r cube. So r into r into r. So on equal to on by 10. If that resultant value is equal to n, the number which we are giving, then we indicate that it is an Armstrong number, or else we'll give that as not an Armstrong number. And for the next process creation, we are giving as PID3 equal to 4. This indicates that the new child has been created, and if PID3 equal to 0, the process has been created, and parent ID is get PID, and child ID is get parent ID is get PPID, and child ID is get PID. And this is to check whether the given number is a prime number or not. The condition for checking whether the given number is prime or not is for I equal to 1, I is less than or equal to n, I plus plus. If the n value, that is the inputted value that is given, the integer value that is inputted over first, percentage I is 1, so that is equal to 0, then we need to increment, and if that c equal to 2, then we will say that it is a prime number, or else the number is not a prime number. For the next process creation as well, we are giving us PID5 equal to 4. This indicates that the new child has been created, and if PID5 equal to 0, process F has been created. The parent ID and child ID for the process is given as get PPID and get PID. So the last one was to reverse the number, right? So for reversing the number, we are giving as while e is greater than 0. MO is the variable which we are creating, equal to e percentage 10. This indicates that the remainder value which we are getting, and reverse equal to reverse into 10 plus the remainder value which we are getting, that is stored in MO, and e equal to e by 10. So the reverse statement the reverse of the given number will be stored in RE. So RE has to be printed. Let us see that. Okay. So the output is parent process ID A with ID is 31,700, and when you are entering the integer value, I am entering integer value as 3. So process B is created, and its factorial number is done, and after getting the factorial number, we need to create the Fibonacci series. The Fibonacci series has been done, and after that, the Armstrong number, it has to check whether given number is an Armstrong number or not. So it is not an Armstrong number, and after that, in E process, it is checked as E is a 3 is a prime number, and process F is for checking the reverse of the number. The reverse of a single digit number is also the same number as well. So reverse of 3 is 3. That's all for the 8th experiment. Thank you.